Welcome back to the channel, Explorers of the Cosmos. Have you ever wondered what lies on the other side of a black hole? What if I told you that there's a theoretical object in physics called a white hole that might hold the key to understanding some of the biggest mysteries of the universe? Stick around, because today we're going on a journey through space, time, and some of the wildest ideas in theoretical physics. Let's start with what we know. Black holes are real, massive objects in space that have a gravitational pull so strong that not even light can escape. They're formed when massive stars collapse under their own gravity at the end of their life cycle. Black holes bend space and time to such an extreme degree that they create what's called a singularity, a point where the laws of physics, as we know them, break down. But what about the opposite of a black hole? If a black hole pulls everything in, could there be something that does the exact reverse? Enter the concept of the white hole. A white hole, in theory, is an object that expels matter and energy. If a black hole can be thought of as an inescapable cosmic vacuum cleaner, a white hole is like a cosmic explosion frozen in time, constantly ejecting material into space. In fact, nothing can enter a white hole because, unlike a black hole, its event horizon pushes everything away. So where did this idea come from? The theory of white holes arises directly from the same equations that describe black holes in Einstein's general theory of relativity. These equations allow for two types of solutions, one for black holes and one for white holes. But while black holes have been observed and confirmed by astronomers, white holes remain purely theoretical. Let's dive a little deeper into the math. White holes were first predicted as part of a solution to the Einstein field equations called the Schwarzschild metric, named after the physicist Karl Schwarzschild. The solution describes a static, non-rotating black hole, but it also has a second, less known part that allows for the existence of white holes. In mathematical terms, a white hole is just as valid a solution as a black hole, but physically speaking, things get much trickier. White holes can be thought of as time-reverse black holes. Imagine watching a video of a black hole sucking up matter, but then hitting rewind. Suddenly, instead of material falling into the singularity, it's flying out. This is how physicists envision white holes, as the opposite of black holes in the flow of time. But here's the problem. Our universe is governed by something called the arrow of time, which always points forward. This means we see things moving toward disorder and entropy increasing, not the other way around. So, while a white hole might be a mathematically possible solution, it's hard to square with the reality of our universe. Even though white holes haven't been observed, there are some bold ideas in modern physics that suggest they might exist in certain conditions. One of the most intriguing ideas comes from the study of black hole thermodynamics and the information paradox. Black holes seem to violate the laws of quantum mechanics because they erase information about whatever falls into them. Some physicists speculate that a black hole could eventually collapse to a point, then bounce back as a white hole, releasing all the information it once consumed. This leads us to an even more mind-bending theory. Could every black hole in our universe actually be a white hole in disguise? Or, more radically, could white holes represent the birth of new universes, emerging from the ashes of a collapsed black hole?